Hello, friends. We are going to talk about solving by elimination today. So, when we're solving by elimination, what we're doing is adding or subtracting the two equations together in our system to eliminate or get rid of one of the variables. So, these are the steps that we're going to walk through. I'm not going to explain the steps to you right now because it'll make way more sense if we are actually going through this process step by step. So, first one we're going to look at here is this system. So, one thing I notice is that the y's are lined up, the x's are also lined up, and the constants are lined up. So, in this case, I'm all set to either add or subtract these equations from each other. Now, if my goal is to eliminate one of my variables, I want the coefficients to be the same number, but the opposite sign. So here, 3x and x are not going to eliminate because they don't have the same coefficient. But these y's both have a coefficient of 1. So what I'm going to do is I'm going to leave the first equation the same. And I'm going to multiply this second equation by -1 so that I will create a -1 coefficient for the second y. So now when I combine these together, y minus y is going to give me 0. 3x minus x is going to give me 2x, and then 4 and 2 gives me 6. Now I'm going to solve and try to get x by itself, so I'm going to subtract 6. So I'll have -6 being equal to 2x. Dividing by 2 tells me that x is equal to -3. Now I can substitute this value into either one of these original equations. I'm going to use the second one just because it looks a little bit easier. So x is -3, excuse me, minus 2. -3 and -2 combine together to make -5. So my solution point is -3, -5. And again, just as a reminder, this is not a calculator unit. All right, here we go on to our second one. Now you'll notice these are both in standard form. Typically, what I'm looking for if I'm solving by elimination is equations that are in standard form. That's the easiest way for us to go because then my coefficients are already together for my x's and my y's. There's no fractions. So usually solving by elimination is helpful for standard form equations. Now again, y's in this case, I have 9 and 10. I'm not going to make those turn out to be 0, but I have 3x and 3x. So again, I'm going to multiply that second equation by -1. So I have 3x minus 10y equals 14. That's not going to change. And then -3x plus 9y equals -15. These are going to create 0, which I don't need. -10 plus 9 gives me -1y. 14 minus 15 gives me -1. I need y, not -y, so y would be 1. And then I can pick either equation and substitute that 1 back into it. So I'm just going to use the first one. 3x minus 10 times 1 equals 14. Well, 10 times 1 is just 10. So I'm going to add 10 to the other side. So I have 3x being equal to 24. So x equals 8. So my solution point is 8, 1. All right, next equation here. This one is already set up for us to eliminate the x's. They have the same coefficient, one is positive and one is negative. So we don't have any work we have to do in this case. We can just start combining everything together. Those are going to create 0. 9 and 7 make 16y. 5 and 11 also make 16. So y has to be 1. Now I'm going to substitute into this first one because my coefficient for x is positive. So 9 times 1 gives me 9, so I'm going to subtract 9 from the other side. If this was any number other than 1, I would actually figure out what it would be multiplication-wise, but it's just 1, so I know nothing's going to change. 5 minus 9 gives me -4, so that tells me x has to be -1. So my solution point is -1, +1. All right. So now you'll notice that one of them is in standard form, the other one is not. I need to get this into standard form by subtracting 3y. So with both equations in standard form, that's my new looking system. I'm going to multiply this one by -1 because it could be the first one or the second one. It does not matter. So I'm going to have 2x minus 3y equals 16. Multiplying by -1 gives me -x plus 3y equals -11. These are going to create 0. 2x minus x leaves me with just x. 16 minus 11 gives me 5. So now I can choose either one of these equations and substitute x in. So I'm just going to use the first one. Subtracting 5 from both sides. So 11 minus 5 is going to give me 6, which leaves me a y value of -2. So I've got 5, -2. Oops, sorry. There you go. 5, -2 is my solution point. All right. Got 2 more where my coefficients are going to be the same, and then we're going to kick it up a notch on the next few examples. So here you'll notice 3 is positive in both of these, so one of these has to be multiplied by -1. So then that'll be -3x plus 4y equals +13. In this case, the x's and the y's are both going to leave me with nothing. So I have to write 0 in this case because there's nothing left on the left side. On the right side, -10 plus 13 gives me 3. Well, that's false. Since that is a false statement, that means there is no solution. There are no values of x and y that will make both of these equations true. So that means these two lines are parallel. They'll never intersect. We got no places that they're going to cross over. Let's check out this next one. Well, let's subtract 2x over. So my first equation is just going to stay how it was. Subtracting 2x over gives me negative 2x minus y equals 10. Well, x's and y's both are gone and create 0. Negative 10 plus 10 gives me 0. This is true. Since this is a true statement, this is where we get that infinite solution thing. This means I have the exact same line and they're going to cross in every single spot because they're the same line. All right. So those examples are when x and y have a similar coefficient and I don't have to do any tweaking beforehand. Now I'm going to have to do some tweaking beforehand. Here, x and y, neither of them have the same coefficient. So, is it going to be easier for me to make 3 and 7 look the same? Or is it going to be easier for me to make 1 and 2 look the same? Well, I'm going to make 1 and 2 look the same because that's only going to take one step. I'm going to take this whole first equation and multiply it by 2. But since x in my second equation is positive and I need to make it 0 x's, I'm going to multiply this by negative 2. So the 2x minus 7y is going to stay the same. Oh, that should say equals, not plus. So sorry. Now multiplying this whole equation by negative 2, I have negative 2x minus 6y equals negative 12. X's are going to create 0. Negative 6 and negative 7 make negative 13y. Negative 12 and negative 1 make negative 13. And the only way for this to be true is if y is equal to 1. Now, I'm actually going to go back to this first equation here to substitute because it has the smallest coefficients. I could use this tweaked equation, but I want the smaller coefficients to find my x value. 3 times 1 makes 3, so I'm going to subtract 3 from both sides. So x would be 3. So this solution here is 3, 1. All right. Next, we've got 3x plus y equals 2 and 6x plus 2y equals 4. So in this case, I'm going to just look at the x's because I'm a creature of habit. I usually look at x first. 3 and 6, I can easily make those look similar. I'm going to multiply the first equation by 2. But since I want to eliminate x, I need to multiply by negative 2 so that these are positive 6 and negative 6. So the first equation is going to become negative 6x minus 2y equals negative 4. And then the second equation is going to stay the same. X's are going to create 0. Y's are going to create 0. So that side's just going to be 0. Negative 4 plus 4 gives me 0. 0 equals 0 is true. So So this is infinite solutions. All right, final two examples. Now, in this case, if you look at x and y, neither of these coefficients could easily look like the other one. That means I have to multiply both equations by some number to make the coefficient of either x or y look the same. So 3 and 15, their least common multiple is, 3 and 5's least common multiple is 15. 3 and 4's least common multiple is 12. I'm going to go with y in this case because that's a smaller common multiple. So in order to make 3 look like 12, I need to multiply by 4. And in order to make 4 look like 12, I need to multiply by 3. Now, one of these has to be negative because right now both of my y's are positive. It does not matter which one you choose. So now I'm going to go ahead and start multiplying. So 3 times 4 gives me 12x. 3 times 4 gives me 12y. And 9 times 4 gives me 36. Ooh, that got worse. There we go. Okay. So now I'm multiplying by a negative 3. So 5 times negative 3 is negative 15x. 3 and negative 4 give me negative 12y. And then 10 and negative 3 is going to give me negative 30. So my y's are going to become 0, which is what I wanted. 12 minus 15 gives me negative 3x. 36 minus 30 leaves me with 6. So this tells me that x is negative 2. Does not matter which one you substitute back into. Personally, I choose the one with the smaller numbers. So 3 times negative 2 plus 3y equals 9. So negative 6 plus 3y equals 9. I'm going to add 6. So 3y is 15. So y has to be 5. So our solution point is negative 2, 5. All right, last but not least. Now, both of these are not in standard form, and I'm going to have to tweak coefficients. So, first thing I'm going to do here, says 2x minus 4y equals 18, and negative 5x minus 6y equals 3. Now here, in my mind, both of my y's are negative, but the x's have a positive and a negative. So in my mind, the x's are already kind of set up for me to start elimination. So I'm going to multiply this first one. 2 and 5, their closest multiple would be 10. So I need to multiply this one by 5. I need to multiply this one by 2. So 2 times 5 gives me 10x. Negative 4 times 5 gives me negative 20y. And 5 times 18. Well, let's say I don't know that off the top of my head. That's like 10 times 5 and 8 times 5. Well, 10 times 5 is 50. 8 times 5 is 40. Adding those together gives me 90. So that tells me that 18 times 5 is 90. Now the second one's getting multiplied by -2. So 2 times -5 is -10x. 2 times -6 is -12y. And 3 times 2 is 6. X's are 0. That's what we wanted. -12 and -20 make -32y. And that's 96. So how many 32s make 96 is the question. So I know my y value is going to be negative. Well, 3 times 3 is 9. 2 times 3 is 6. So that tells me 3 32s gives me 96. And it has to be negative since it was -32y. Now I'm going to take this value. I'm going to substitute it into this first one, just because x is kind of already almost by itself. So I have 2x equals 4 times -3 plus 18. That's -12 plus 18. Well, 18 minus 12 gives me 6, which means x is +3. So here my solution is +3, -3.